So yeah, this is the Golang Live series here at Amicus. I'm your host today, Dominic Taylor. So I specialize in recruiting for Golang engineers across the US. But here as a business at Amicus, we specialize in a few niche programming areas such as Golang, Rust, JavaScript, machine learning, cloud and DevOps, and also AI. We work with businesses right across the US, the UK, and also Europe. Now, the reason why we do these podcasts is to really provide an opportunity for senior engineers like Dave to showcase their skills, also to provide some really valuable content for you guys to make sure that you have an opportunity to learn, to upskill, and see where you can improve in certain areas in your skill set as well. Dave has over 5 years of experience now using Golang at the likes of Nasuni and CrowdStrike. So it's going to be a really cool presentation. I'm sure there's going to be lots of tips and tricks for you to take home. But yeah, as I said, without further ado, I'll let Dave take over. Really looking forward to this one.
Awesome. Thank you very much, Dom.
No worries.
Okay, do you see a Google Slides presentation?
Yep, all good.
Excellent. I'm going to go ahead and turn the laser pointer on. So this is a presentation that I've put together called Enhancing Unit Tests with Mocks. So before we dive in, I'll give a little intro to the background that I have. I graduated with a degree in applied mathematics back in 2015. I got my start as a software test engineer. I did that for about a year, and I've been a software engineer ever since for the past 7.5 years. It's hard to believe, but 5 of those have been working in Go. I actually recall the first Go program that I ever wrote. The company that I was at had a load tester for a very data-intensive app. The load tester could emulate about 8,000 clients, but we needed more performance out of it as we started to scale and take on bigger client bases. So we wrote it in a more performant language. Go was that language. In just a simple translation to using Go instead of Node.js got us about 30,000 clients per load tester. So a 3.5x improvement just by moving to Go, and I've been sold ever since. So I've been working in file storage, cybersecurity, and telecom using Go. And I've worked on a variety of different applications from cloud services and SaaS offerings to on-prem Kubernetes applications to load testers and CLI tools, all of which Go does very, very well. So for the agenda for today, we'll be talking about what unit tests are and why we should use them, what mocking is and how we implement mocking in Go. We'll be talking about code generation for mocks. And then I'll go through a couple of real world examples of applications that I've tested using mocks. I want to talk more about the concepts today and not get lost in the complexity of code. So some of the examples that I've come up with are intentionally simple, so that we can talk through the concepts, but we'll go through some real world examples later and what mocking will not do for you. And as Dom mentioned at the beginning of this presentation, I do have pause slides at the end of each section here. So please fire off your questions as they come in, and then we'll answer them at the end of each section so that we can quickly jump back to the slides that they might pertain to. So what are unit tests? It's code that you write to test your code. You call your function, you get the result of your function, and you validate that or the error that your function has given back. And because you are controlling the inputs and validating them against the outputs, this gives you the ability to write tests against data that you've actually seen in the field. So why should we write unit tests? This validates code correctness before it hits production. You run tests locally, and you can run the tests as soon as you write them. So you don't need to deploy your code to wherever it will be run. This is true for new code as well as changes to existing code. Say that you have a slow function, you want to optimize it to make it go faster. If you have 8 tests or a test suite against it, you can validate that you did not break any of the existing functionality. The testing package is also part of the standard library for Go. The Go devs really want us to write tests. And if a bug does make its way into production, you can grab the data that your function was incorrectly performing with, and you can write tests against that input. And so this prevents the same bug from occurring twice. You can also step through failing tests with a debugger, and we'll be going through that in a couple of slides here. And it gives you great insight into what your code is actually doing on a line-by-line basis. And tests also serve as great documentation for expected behavior. Developers will write comments in code as well, but if you change a function to behave differently, you might break something that was unexpected from your end. So first off, we're going to create a couple of functions to write tests for. So I've made a math folder with an operations.go. We're calling this package math. And we've got two functions here. We've got add, it just takes in any number of ints, and it's going to return the sum. And we've got multiply, it again takes in any number of ints and returns the product. So in order to create unit tests, we're going to create a file named after the file with the code that we're testing with underscore test.go at the end. So ours was operations.go. We'll create an operations test.go. These are just regular Go files. So we'll be defining the package name and the imports at the top. If you want to create a new test, you'll be defining a function called test with the test name. And the only thing you have to do is capitalize the first letter of name. And the only parameter that this takes is a testing.t. This comes from the standard library. And so we'll see that on the next slide. Inside of our testing function, you call t.run, where you implement the testing logic. You can make an assertion where if the assertion fails, your test goes on and it continues to execute the remainder of the test. And there's a library to help out with that. And then you can also make requirements from inside tests where if a requirement fails, the test stops at that point. Say that you give back a pointer and an error, and your error is not nil. Your pointer could be null, and you don't want a null pointer dereference. So you could require that your error is not nil before moving on. And there's also a helper library for that. I'll be showing you what table tests are. It's a way to quickly parameterize tests and so that you can spend more time configuring tests rather than writing the same logic over and over. And if you want to run the test for a package, it's one command from the command line, go test dot slash dot dot dot. That dot slash dot 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 is short for the entire package that I'm in. And you can run tests for individual files, but this is how you run them for the entire package. So here we've got our operations test.go. We declare our package and the imports that we have. We've created a new function called test add, which takes in a testing.t. This is what table tests look like here. You define a struct inline that pertains just to the current test that you are working on. And the struct fields are the parameters of your test. So every test is going to have a name. We're testing the add function, so we take in a list of ints here. And then we have the expectation for what these numbers should add up to. So I've written a couple of examples here where if we have no numbers, we should add up to 0. There's a test case for positive numbers, and then there's a test case for negative numbers as well. We're going to loop over all of our test cases, and we're going to call t.run to execute the logic of our test, where all we're doing is simply calling the add function with our test cases nums, and we are asserting that the expected value is what we got back. And so here, if we go to the command line and we run go test for the package, we can see that our math tests are okay, and they took 0.049 seconds to run. So we're going to also add tests for the multiply function, where again, all these tests are going to have a name, the numbers that we want to compute the product of, and the expected value. And we've got the, no number should multiply out to 0, and then all positive numbers, 1 times 2 times 3 should be 6. So if we run this from the command line, we can see that test multiply for all positive numbers has failed. We expected 6, but we got 0. So let's take a look at what's going on here. I'm using VS Code as the editor for this presentation, but a lot of other IDEs and code editors offer similar options here. Here I can run the test in isolation, but I also have the option to debug test. And so if I debug test, what this allows me to do is put in a breakpoint, and at breakpoints, the code execution comes to a halt. You'll get a few options for how to proceed, and you'll also get a view of the current variables that your test has access to. And to put a breakpoint in VS Code, you click to the left of the line number, as shown by this red dot here. So when you debug tests, this play bar at the top will show up, and there's a few things that you can do here. So there's the play arrow, which is this first one here. This will execute code until the next breakpoint. So for here, I'm on the empty set multiplies to 0. That test was actually passing, so I'd like to hit the play button so that I go to the next test in my loop here. There's the step over function, which is this one. This allows you to move code execution onto the next line, and then you can decide what you do from there. There's the step into button. So this actually allows you to go from the code that's being executed into the function that it's calling. So if I said step into on line 60, we would jump into the multiply function. Step out allows you to step out of the function that you are currently in. So if we decide that multiply is okay, we can step out, and then we'll be at this point again. You've got the restart button to restart the current debug session, and the stop button to stop the current debug session. So if we step into the multiply call, what we'll see is we have our list of ints 1, 2, and 3 that we're expected to multiply out to 6. And we are setting total equal to 0, looping over our numbers, and setting total times equals our number, but anything times 0 is 0. So because we can get a good sense of what's going on, we've identified what the bug is. So let's fix that bug. So instead of starting our total at 0, we'll start at 1. In that way, we'll essentially assume the first number that we start looping through. And when we run the test again, our empty set multiplies out to 0 test is now failing, but our positive number test case now passes. And so if we have no numbers here, total will be set to 1. This loop will do nothing with an empty number list, and we will return it at the end. So now we can actually fix the bug for real and do a length of number check to make sure that we actually have numbers. And if we run these tests, they now all pass. So yeah, I hope that was a valuable oversight into what unit tests are and how you can step through them to identify any bugs that your code might have, especially if you've written a test where the expectation is not lining up. So are there any questions on unit tests? Okay, I'm getting the go-ahead from Dom that we don't have questions here. So let's jump into a hypothetical. Let's say that you're working for a company that makes a humidity sensor. And these are just little IoT devices that you can put in basements and restaurants, and they take a measure, they report their measure to some API, and there's a processor that does some pre-processing. They validate that the sensor that's checking in is for a customer that is still paying. They might do some things like add customer ID and sensor ID so that you can tell who the sensor belongs to. And then they dump the results to an Amazon S3 bucket. And you are tasked with reading the results of these sensor readings from this bucket and writing them to a database so that end users can take a look at trends and set alarms and just view all this data for the sensors that they own. So this is a hypothetical that we have, and I'm just going to go over a couple of the technologies that are outside the purview of Go, just for people that may have not come across them. S3 is AWS's simple storage solution. You can think of it like a file system with an unlimited amount of space. So buckets in S3 hold objects. And so this is kind of like a C drive on Windows or a partition in Unix. These objects have a path, so you can kind of think of this like a file path, and these paths have contents. And so this is kind of like a file. So S3 is basically like a file here. And then Lambda is an AWS serverless function. You define triggers and you write code to act on it. In this case, whenever a file is uploaded to S3, you can have an event emitted to your Lambda code. And Lambdas offer a lot of different features, from logging to handling of failed messages, monitoring for memory consumption and CPU, and a few other things like that. So let's take a look at what some of that sample code could look like. Down at the bottom, we have our main function. AWS has a Lambda package where you can start a Lambda code to execute when we have a event. And the function signature for this takes a context object as well as the S3 event. You can choose to batch these events. So we're going to be looping through all of them, determining the name of the bucket and the path. We're going to grab the file contents based on those and perform an error check. We'll then create an array of humidity stats, and we will unmarshal those stats into our array here, doing an error check along the way. And then finally, we'll write the records to the database. And if we are able to process all the S3 events successfully, we will return nil for the error. And then the humidity stats might look something like a reading, a unit, a customer ID, and a sensor ID. And this get file contents based on the S3 record, we'll take a bucket and path. And then AWS offers a helper to load the configuration for the resources in AWS that you have access to. Using that configuration, we'll create a new S3 client so that we can do operations with it. And then we will call get object. We'll pass it just a background context, basically an empty context. And then we'll also give it our bucket and path. And we'll make sure that we are able to successfully read that file. And if we can, we will read the raw contents out, error check, and then return it at the end. And then our database code might look like looping through our stats and doing a SQL insert at the end. So if you had to write a test for this, how would you go about that? There's a couple problems that you would have to take on first. For example, connecting to an S3 bucket. Do you want to have a real S3 bucket that you can write tests on? This costs money, and you also need magic values. You always need to have that bucket name and maybe a path that you want to work on. And you also have the problem of, what if someone else is writing tests using the same path in that S3 bucket, but with different data? You might conflict there. You also have to store the AWS credentials to connect to that S3 bucket wherever you want to run tests. So that includes your laptop, and you might have GitHub Actions automatically run tests every time you push code to it. And what happens if S3 goes down, or if S3 is okay, but the internet connection that you have goes down? Your test will intermittently fail for reasons that are out of your control, and you'll waste time debugging failures there. And if you were to, in GitHub, every time you push code, if you were to build the Go binaries at the end, but you gate them by tests, you can actually prevent build artifacts from coming out there. You also have the problem of making sure that your code handles failures in S3 properly as well. If it's properly functioning, you can't really make that fail. And the database writer has all the same problems here. So this is where mocking comes in. So mocking is a strategy for unit testing. You use dependency injection to remove your code that interacts with the real dependency and interacts with something that looks like it. Because you're controlling the behavior of the injected dependencies, you can test what happens when you are able to successfully interact with it, as well as the case when the interaction fails. So there's a couple of steps to achieve mocking in Go. The first one is to define an interface with the function signatures that describe the interaction with the dependency. You create a struct that implements this interface that actually communicates with the dependency. This is the code that you'll use in production. And then you'll also create a struct that implements the interface, but it does not communicate with the dependency. And this is what we'll be using in unit tests. Finally, we'll create a constructor that takes in all the dependent interfaces. And this is going to help us track what dependencies are used. So we'll go through our example of our humidity sensors writing to our API, them ending up in S3, us reading them out and then writing to a database. So for step one, we're going to create two interfaces here. The first is an S3 reader. We want to get the object contents given the bucket and path, and we'll give the raw bytes in the file and an error if we ran into one. And then we define a sensor ingester interface as well, where the only function is to write the humidity readings and to return an error if we encountered any. So if we were to implement the interface for S3, I've created a service folder with an S3 package here. I've made a reader that holds on to an S3 client connection, as well as a timeout for the S3 operations that we have. And this looks very similar to the code from a couple slides back, where we get our default credentials to interact with AWS. We're going to create a new S3 client using those configs and then return our reader. And we're also going to define this get object contents to make our reader implement the interface, where we take in bucket path and return the file contents. And this code is exactly the code from a couple slides back, just broken out into this new function. For the database, this is going to look pretty similar as well. We've created a sensor writer struct that has a connection to a SQL database. Perhaps we're storing this in Postgres for now. And to create a new sensor writer, you need a DSN, which is a connection string saying what host and port the Postgres is being hosted on, as well as a timeout for all the write operations. We'll open a connection to that Postgres database, error check, and then return our sensor writer struct. And then to implement the interface here, we're going to have a write humidity readings function where we just loop through the readings that we have and executing a SQL insert for each one of them. So now we're going to implement the interfaces for testing. So I've created two structs. We've got our S3 mock, which is going to have the return value of our getObjectBytes function, as well as the error. And to implement the interface, we're going to define getObjectContents given the bucket and path. And we are going to return the values that we've configured our struct with. And then our database mock looks very similar. Write humidity readings only gives an error back. And so we're going to have it be configurable with the error there. Now for the, we're going to define a struct that has a constructor for all of the dependencies that we have. So for this application where we're reading out of S3, processing, and writing to a database, we need an S3 reader and a DB writer. So here's the constructor for that. And then there might be a little helper function that, kind of creates these clients for us, just so that if there's multiple entry points using this code, we can have one clean function for it. And that's exactly what we're going to do. So we're going to get our processor, making sure that we can connect to both our database and the S3 reader. If we encounter an error connecting to either of those services, we're going to panic. Otherwise, we're going to start our Lambda function to do the perform ingest. And now this is defined on our sensor processor struct instead of just being defined as a function. And the only difference is it's using the interfaces that our struct has access to on the S3 read operations, as well as the database write operations. So just a reminder, this is what the mocked structs looked like. If we wanted to write tests against our perform ingest, we'll also need to grab some mock S3 events. So I've created a little helper function here where you give it the number of S3 records that you want, and then it will return populated S3 structs with bucket names and object paths. So again, using our table-driven tests, we're going to come up with all the parameters that we have for our test. So we'll have test name, we'll have the S3 event that we're acting on. We're going to control what our S3 get object call gives back, both the contents of the file and the error. And then we'll have we'll get to specify if the database write fails or not. And then we have this should error Boolean to determine if the input that we give it should produce an error or not. And so the test cases that I've come up with is a valid reading. We'll be processing one S3 mock event. And what I've done is created a valid humidity reading object. And I have marshaled it to a JSON slice that we can use for this test. Then I make sure that if we have an S3 error, that our do ingest function bubbles that up, and the same for a database error. If S3 is able to succeed and give us back the valid bytes, but our database write fails, we make sure that that error is returned to us. And so here we're just looping through all the test cases that we have. We are creating our mock structs. When I create the mock S3 reader, I'm specifying the bytes and the error to give back from our call. Same for the database writer. We're then making a new processor, taking in these structs that implement the interface, and we're calling our perform ingest function. And then we're validating the error if we should have one. Otherwise, we're validating that no error happens. And so if we run tests against our package, you can see that we have a ingest app, and all the tests passed in 0.068 seconds. So leveraging this new infrastructure that we have for writing tests against a service that interacts with S3 and a database, you might want to ask the question, what happens if I put invalid bytes in the S3 file? Right now, we're only ingesting humidity readings, but what happens if we create a new struct for a temperature reading that looks completely different? We create a struct, we JSON marshal it, and we use these invalid bytes as the return value from the S3 object. We might expect to encounter error because our data shape is not what we want. And so if we run our test now, we see that we expected an error, but we got nil, we got no error. So what we're able to do is debug this test. And so we can see that we're in the perform ingest, we're looping through the S3 records, we're grabbing the file contents from S3, and we expected this code right here to fail, and we would expect the function to break out here. However, we are able to reach lines 67, which means that we're past that point. And so if we take a look at our readings, which we are unmarshalling the S3 contents into, you can see that we've got one reading where all of our struct fields are the zero value. So we've got 0 for ints and an empty string for the string. So why is this happening? Well, stepping through this test shows what the symptom is. We expected JSON unmarshal to fail, but it does not. The default JSON unmarshaler, if you have an extra key, it will not do anything with that key. And if you have a key that you're expecting to be set that's not set, it will just set it to the 0 value. So this is just a little intricacy of how the JSON unmarshaler works. And so that's why we have one reading that's populated by all 0 values. So if we wanted to fix this bug, we would create a new decoder and base it on the file contents that we have. And then you can disallow unknown fields because you don't control what the sensors send to you. And so you might want to do payload validation to make sure it's a data that you can actually process. And then we will call decode with our new decoder. So if we run these tests again, we now see that the invalid data shape test passes. So just a recap on why we should use mocks. You can achieve better test coverage with them. You know, these 2 lines of code for the unmarshaling was sandwiched between an S3 read and a write to the database. If you didn't have mocks, you would not be able to test that code and see that it actually fails if you get data that you're not expecting. And you can test code that interacts with outside systems. You know, we came up with a couple of test cases where S3 failed, our database write failed, and we made sure that the system returned the error there. So you're really controlling the behavior of everything that you mock, which allows you to test both the success and failure cases. We were able to debug locally. We had a failing test. We could step through, get great insight into what was actually going on. For example, Lambda does not allow you to attach a debugger to it, so you would have to add logs or other observability metrics in to be able to diagnose what's going on there. And we were able to actually step through line by line and get insight into what our code was doing. You've got very well documented tests because you're able to test both the success and failure case. You know, you can add things like making sure that a retrier gets called the proper number of times, and you just have very well documented tests for what should happen under a variety of scenarios. This one actually did not come into play in this example that we have, but speed, you know, let's say that you're dealing with an ML model that's processing lots of data and a computation takes 10 minutes to run. You can mock that computation out so that your unit test can run very quickly depending on the model output. And it also encourages good structure of code. The first example that we have, we just had functions to get the files from the S3 contents. Let's say that you were creating more and more Lambda functions that also needed S3 reading. What we had to do was define an interface for how to interact with S3, and we'll be able to reuse that S3 reader class across multiple different entry points for code. And also, let's say that you wanted to swap out a technology that you used. Let's say Postgres wasn't holding up. You wanted to move to a different database function. The interfaces define a clear set of the functionality that you need to implement in the new technology if you want to move to one. So do we have any questions on mocks? Okay, I think I'm getting the go ahead from Dom to continue right on.
We do have a question, sorry.
Oh, yes.
Yeah, Chris has just said, I have a question. So Chris, do you want to kind of type the rest of the question there? Ryan Johnson's also shared a demo based on what you've been discussing as well. So yeah, we can share that for people viewing this later. Chris is just typing out the question, so we'll just give him a moment.
Okay, yeah, sure. Yeah, mocking is I think it's a very unique testing strategy. It's just that it's very simple, but it's very powerful what you can do with it. So I'm certainly happy to answer any questions that folks have.
Yeah. Whilst Chris is typing the question, I did have one myself.
Mhm.
Obviously, you've made this sound incredibly simple and quite standard. I'm sure it is to yourself at this point, but where did you actually kind of learn, the importance of mocking at first?
Yeah, so the first couple Go projects that I had, we had a simple database where we were able to in GitHub Actions, whenever we were running tests via us pushing code up, we could spin up a Docker container and actually have tests that ran against the container. And we were able to have a container locally on our laptop as well. So there's one command, spin your container up, and then all your tests will actually run against it. There was a situation where we had an external dependency that there wasn't a Docker container for. It was an AWS service, that's only available in the cloud. There's no container for it, but we wanted to write tests against it. So the team, kind of did some investigation into it, and that's kind of where I picked that up. So I didn't pick up
Nice.
mocking for 2 or 3 years, actually. I had
Okay.
used mocks in Python, but it's very, very different how Python does mocking to how Go does it.
Right. Okay. That's interesting. Chris has got the question now.
Mhm.
I'll just put that live for you. Can you see the question there?
Let me see. Q&A, fantastic demo. Yeah, sorry, one sec. Okay, what are your thoughts on defining a variable like mockable function like this versus mockable function versus mock function? Um, I want to make sure that I understand the question properly, so I'm going to jump back a couple slides. So the reason that we're using interfaces rather than functions is so that we can control the return behavior. And so when you pass an interface in, it can be any struct that you want. So I'm sorry, let me just get to where I want to go. So here you have an interface. Whenever you say my code takes in an S3 reader, it can take in any struct that has this function signature defined on it. And so that way you can kind of control what goes in. Um, Interfaces I find tend to be better so that you're not setting function names at runtime and it's just clearer what's going on. You can take a look at the actual production code. You can see that we are calling our own S3 package, not the one that AWS offers, where we're making a new reader with the parameters that we have, and we're making a new database writer, again, with the parameters that we have. So this is our production use case, very clear what's going on here. And then when we get to the unit tests, we are creating these S3 mock structs and database mock structs that we can control the behavior of by setting their fields. And so our processor code doesn't know if it has an S3 mock or if it has an actual S3 reader. It just knows that it has a function that defines get object contents based on the bucket and path within that bucket. And so I think I just think it's clearer to go the mocking route with structs and interfaces rather than functions.
Awesome. Maddie had a question as well. I'm not sure if you've seen that one. Um, put that up for you now.
Can mocking improve CI/CD time? Yeah, so let's say that you were actually writing tests against a real database, and let's say that the database operations take zero point 0.2 seconds to run, but you've got thousands of tests, or possibly a very, very old project where you just have lots of database tests being run. You have a couple of problems that you have to deal with. One is the runtime. As you add more and more tests, your tests actually take longer to run. The other is parallelism also. Let's say that you have multiple tests reading from, writing to, and deleting from the same table. you might not be able to run those tests in parallel because one test cleanup method might completely wipe out the data that another test needs for it to pass, and you could see test failures. To the go test command here, there is a -p flag that you can pass in to say how many parallel tests can run at once. And so if you're in that type of an environment, you might have to set the parallelism to 1, so all of your database operations will be serial, making your problem even worse. So yes, they can certainly improve the CI/CD time.
Brilliant. Yeah, really appreciate the questions, guys. That's all for this section, Dave. So if you want to continue on to the next segment.
Yes, excellent. Thank you for the questions. Okay. So let's say that the company that you're at, you're doing very well. The humidity sensors were great. Restaurants bought them to, measure ovens, and homeowners were buying them to measure wet basements. And so you've been able to develop more and more sensors. So you have temperature readings for offices and velocity readings for trucking companies, and you're just adding more and more sensor telemetry that you're able to collect and create alarms on. So you not only have to implement these functions for the interface that actually interacts with the database, but you also have to extend your mocked classes to keep up with the interface as well. And let's say that these structs are shared, so you have multiple applications. You could be adding a function to the interface that your code needs, but someone else's code doesn't. But you still have to go and update the mocks in every single package that actually uses them. And that's just not something that you want to do. So there are some code generation tools, MockGen and GoMock. So MockGen is a code generation tool that writes mocks for you. They take the interfaces that you define, and they actually create structs to implement them. If your interface changes, let's say you add a function or you change the signature, you can regenerate them using one command as well. And there's also some additional features beyond what our hand-rolled mocks did for us. You can validate that certain functions are called a certain number of times. You can do input validation to make sure that your functions are being called with the right set of parameters. You can also execute arbitrary code. Let's say that you've got a retry counter where you make your mock fail the first time, you decrement your counter, and then you make it pass the second time, so they can be very dynamic. And GoMock is a package that helps you interact with the mocks that MockGen made for you. So if you'd like to use them, you can run this command here, go install the MockGen package. Because this is using go install, this is installed globally on your machine, and you can use it any time after you run this. For each package that you want to use mocks in, you'll do go get of this Golang mock link. Then this will become a dependency of the package here. And then you're going to add build tags to the files that you wish to mock. And this is what build tags look like. So we're saying when the go generate command is run, we're going to be calling the mockgen tool. The source is interfaces.go, which is the name of this file here. We're going to put our mocks in a package called mocks. And the destination of that file should be the current directory mocks, mockinterfaces.go. And we'll get mocks out for these interfaces here because that's our source. And if you wanted to generate this, this is the command that you need to run, go generate for the package that I'm in. And so this is the result of calling that code. We can see that we've got a new mocks folder, and it's got a mockinterfaces.go file. You can see that there's a mock IS3 reader. You've got a function to make a new IS3 reader that's going to take in a GoMock controller. This was the library that I was talking about that has helper functions to interact with these mocks. And this mock IS3 reader implements the interface that we have, the get object contents based on bucket and path. and it gives back a byte array and error, just like the interface says that it should. So we're going to, when we swap out our hand-rolled mocks for these code-generated ones, we're going to create a new controller using the mockgen package. This is what actually spies on your mocks and validates that they're called the proper number of times, and it does the input validation for you. You defer controller.finish, so it runs at the end of your test to validate that the expectations were actually met. You're going to create a mocks was the name of our package. So we're going to be making mocks.new S3 reader, for example. It's going to take in that controller that we made. Then we're going to set the expectations. You do that by saying, mock.expect dot function name. Your interface may have multiple functions, so you can specify which ones are called, and you give it the args that it is called with. You can either have it called any number of times, or you can specify that it gets called a certain number of times. You can control the return value like we could with our hand-rolled mocks. And then you can have a do function that just executes arbitrary code. And these are going to become the interfaces that you pass into your testing functions. So as a reminder, the application that we're working with, sensor reports data to some API. There's some pre-processing code to add some additional fields. These get dumped to an S3 bucket, and when that happens, we're going to read the data from the bucket and write it to a database after. And so this was the same testing harness that we have. So we're making a new controller here, calling defer of the controller.finish to validate that the expectations were met. We're making a new S3 reader and a new database writer with our mocks package. We're setting the expectations here. Previously, we were in our hand-rolled mocks, we were just setting the return values to the bytes that we wanted from our file and the error. But you can actually see that we're getting additional input validation here, saying, hey, make sure that get object contents is called with our bucket name and our bucket key. So this makes sure that your arguments are being passed in the proper order. We know that the S3 call should be made exactly one time. We don't have a retry if it fails, and we're going to give back the object bytes and error. Now, we know that we only get to the database portion if we have no S3 error, so we're making sure that the error is nil, and if we don't have a JSON parse error. If both of those are true, we're telling our database writer that it should be expected to call write humidity readings. We're not doing input validation here, so this is another GoMock helper to say, hey, we'll just take in anything and that's okay. We'll know that we'll do it one time and return the write humidity error that we've configured our test case with. And then the rest of the code is unchanged. So if we go test against our package, our tests are still passing with these code-generated mocks. I did want to give a quick example of do, because I think do is really great. So let's say that your code under no circumstances can panic. And panic in Go is when an invalid operation happens. Like let's say you have a pointer that's null and you dereference that pointer, panic happens there. When you're using a third-party library, you might not be reading all the code that goes into that library. And so let's say that you want to have a really defensive program that accounts for any panic that can happen, and you have a panic handler. Perhaps it notifies you via Slack or via email. It just says, hey, your code has panicked, and gives you the reason for that panic. So we have a new interface here. So we're going to regenerate the mocks that we have. And then we're going to write this code here. Let's just say that we want to be able to get S3 file contents and pretty print them in a JSON format that humans can use. We'll have a defer function to check if any panics happen. And if they did, we will call the panic handler with the reason that the panic happened. Then here we'll just get the S3 file contents, unmarshal them into an arbitrary map. We don't care what the data shape is. And then JSON Marshall indent. This will essentially pretty print your JSON. So if you have nested JSON, it will essentially nest it for you and returns to you those bytes. So this is the parameters for a complete test harness for how you would test this, but we're just going to go through the panic handling here. So we've got, validate that our panic handler gets called if we have a panic, and our panic reason is going to be feeling blue. We'll create a new controller, and we'll finish it at the end to make sure that the expectations were met. We'll have an S3 reader and a panic handler. And if we have a panic reason, it's not null. We'll set the S3 reader mock to expect to be called. We don't care about the input validation here because we're just testing panic handling. It should be called one time, and it's going to do. And the do function takes in the same function signature here. So we've got our bucket and key, and we're just going to call panic for our panic reason. And we know that when this happens, our panic handler should be called once, and it should be called with our test cases panic reason. If there's no reason to panic, then we just ensure that the S3 reader is called once. We'll make a new reader given the interfaces that we have, and we'll call our new display function with the dummy bucket and dummy key. And so if we step through this test, we can actually see that as we step through, our S3 mock has panicked. We recover at this top level here. You can tell because the reason is not null. And we are indeed calling our panic handler .notify. So yeah, GoMock and MockGen are two really great packages that reduce the burden of having to come up with your own hand-rolled mocks, extending them as the interface grows, changing them when the interface changes. They just save a lot of time. So do we have any questions on our code-generated mocks? Okay.
Yeah, looks like there's no new questions, so feel free to continue.
Okay. So now that we've gone through what unit testing is, how to define table tests, how to test complex code that has external dependencies, these examples that I went through were a bit simple. We had some math operations, we had an add and a multiply function, and then we had some code that read file contents and wrote them to a database afterwards. So I just wanted to go through some examples of past things that I have mocked that are a little bit more complex. Kinesis Stream is a service that AWS offers. You can kind of think of it like a queue. It's for very high throughput systems where you have a lot of writers writing to this queue and they pile messages up. You can keep track of where you are in this Kinesis stream with a sequence ID. If you've got messages up to here, but you've read, this first half, you will have a sequence ID that corresponds to this message, and you can continue reading from there until you catch up, kind of like an offset of a Kafka queue. If you have a Lambda trigger, and your Lambda returns an error, the sequence ID is not advanced. So if you have one message that you, for whatever reason, cannot process, let's say you panic when you try to read it, you can lock your code to trying to reprocess the same message over and over. And from the AWS documentation, they put they say that you need to handle bad messages in code. You can't rely on the behavior of Lambda failures to handle them for you. So again, you need to account for data shapes that you can't handle. You need to have a strategy put in place for when something goes wrong. So you need a dead letter processor. You need to be able to handle code when it panics. Let's say that there's a third-party library that panics. You need to be able to handle that even if the code that you wrote does not panic. I was able to write tests that validated that if we do get a bad message that we couldn't process, a popular strategy there is to have a dead letter queue, where the message sits in the queue until a person comes along and says, hey, why was this message bad? And then you decide what to do with it from there. And then I could also validate that the Lambda function code never returned error. And if someone comes down the road and says, oh, hey, we have these bad messages here, but we're not returning an error from Lambda, we really should be, and they change that, the test will now fail, which is great because you do not want the Lambda to ever return error. And then one more example to walk through briefly is a health checker. There's an application I was working on that had multiple components to it, and I needed to validate that they were all in good working order. We were running the application in multiple data centers. So if one data center was marked as not healthy, we can move all the traffic over to the other. We had multiple sources that were interested to see if our particular data center were up and running. And so these health checks were running very frequently from disparate sources that we did not have control over. And in the AWS ecosystem, you pay per API call to get health metrics from what they collect for you. And so if you ran a health check and then you run a health check 10 milliseconds later, nothing has changed in that time. And so we were able to put a caching in front of the individual checks, but be optimistic on it. Say, hey, if things are looking good, then we will assume that they're good for the next minute, for example. But if things are looking bad, then we want to know the moment that the services come back to good health. And so this allowed us to validate that, if we had a healthy app, if we ran our health check twice, we would only hit the mocked API call for that particular component one time, if you run the tests or if you run the health check back to back. And if a health check came back as failed, we were able to validate that the cache did not get updated, so that you would actually make those API calls again and again until we were back in good health. And then let's briefly talk about what mocking will not do for you. Let's say that you're running in a cloud environment. The way that AWS knows what components can talk to other components are through permissions. So you create policies that say that what you are allowed to do. So you'll be able to send a message to a particular queue. You can attach policies to roles, and then you attach roles to individual AWS services. And so here we've forgotten to attach the API gateway role to our API handler. And so if a sensor were to turn on and try to communicate with us, the call to put the message in the queue would fail, and the sensors would think that the API is down. So mocking will not help you validate that the permissions are properly set up. We'll just allow you to test what happens if your API is down or not. The solution here would be to have infrastructure as code. This allows you to provision your infrastructure the same way against both a production environment and a pre-prod. Then you can provision the infrastructure in the pre-prod environment and then hit your API to validate that your data makes it all the way from sensor, to your processor and makes it to the database at the end here. Inter-team payload validation. Let's say that the sensor team is a completely different team. They're sending you JSON payloads that look like temp with a number and unit with a string. So they're sending that to the API. They're getting popped into a queue, and your Lambda is expecting that data to be in one JSON field called temp, and it expects 55C. All of these messages are going to fail. So your API will be healthy, but your dead letter queue will pile up and your database will have nothing in it because every message is failing. So there's a couple things you can do here. Protobuf is a language agnostic code generation tool. So you can create a proto file to say, hey, this is what a temperature reading looks like. Then, let's say that the sensor is written in C. They'll get C structs that they can populate and send to the API. then you can use code generation to generate the Go code from those proto files so that you can ensure that you're talking in the same data shape. Let's say that you go with an untyped thing like JSON payloads. You can have documentation that each team shares. And then you can also write end-to-end tests in the pre-prod environment. You can use an actual sensor to communicate with the API that you have, or you can just use a VM that's running the same software that the sensors run to check in to hit that API, and then your test harness can check for the database reading at the end. Scale, let's say that your company starts off small. We only had one sensor, maybe we had a couple hundred clients. As you have more and more of these sensors checking in with the API, are you going to be able to handle that traffic? You can't know just by looking at the architectural diagram that you've put together. So you'll really have to kind of come up with the production volume of data that you think you'll see, and you can create a load tester to match that volume. And you can also read the service documentation to see how many API calls per second the various technologies that you use handle, how scaling works, scaling up and down. And so just getting a sense of if the amount of production volume that you can have will overwhelm the services that you'll use. And monitoring is the last thing here. You cannot tell if this environment is healthy just by taking a look here. But there's lots of solutions to tell if your application is in good working order. You can have log collectors and you can do pattern matching on them. Let's say that your API server, logs that it served a 200 okay when things are going well, but let's say that you log a 500 if something has gone wrong. You can monitor for the rates of 200 okay versus 500 server error. And all of the major cloud providers provide a way to monitor the individual resources that they use. So for Lambda, you can get insight into the invoke time, the error rate that the Lambda function is having. You can get metrics on how many of these bad messages are being sent to your dead letter queue. And so you can just create some metrics based on these. So yeah, this has been my presentation on enhancing unit tests with Box. I just wanted to thank everyone who has attended today. Dom, thank you for hosting me here. It was a lot of fun putting this presentation together, and I really hope that folks were able to learn something new or gain some value from it. If you would like to reach me, I am on LinkedIn. I know that this presentation will be going up on YouTube after, so if you either weren't able to get your question typed up in time, or if you are watching this in post, please feel free to connect with me and ask any questions that you have. I do have a personal GitHub. I am going to be honest, I do not post too often, but all the code in these slides are available there. I have a Go Live mocking repo, and the way I've separated it out is one branch per section. So part one unit test, and it'll have the math functions that we put together. And yeah, that's it.
Awesome, that was great, Dave. Really appreciate the level of detail that you've gone into there. You can clearly tell you've put in a lot of work, and you definitely know what you're talking about from my perspective anyways. And yeah, that was awesome. If anyone does have any questions, as Dave said, there are his links, so feel free to reach out to him directly. If you do want a copy of the slide or anything like that, I'm sure Dave will be able to share that with you as well. I'll just give the kind of floor to the guests who are still here. 10 seconds. Are there any final questions before we kind of wrap up and close? Nope. No worries at all. So yeah, if you do have any and you think of anything later on, feel free to reach out to Dave directly. If there's anyone in the room who would like to feature in something like this in future, feel free to reach out. If you are a Golang enthusiast like yourself and are looking for your next opportunity, myself and the Golang team of recruiters here at Amicus will be happy to help you. As I said at the start of the call, we recruit for the US, UK, and also Europe as well. So feel free to reach out. But yeah, it's been a pleasure. Hope you guys enjoyed it and picked up on a lot of tips and tricks there. for myself, there was a lot of information that kind of went over my head. So I'll definitely be watching this again to try and take something from it, even from my perspective. But yeah, that was great, Dave. Really appreciate your time. Do you have any final words yourself?
Um, yeah, I mean, I think the tech world has gone through a little bit of a rough patch these past couple of years.
Definitely.
So if you do have the fortunateness of being happy with where you work and a recruiter reaches out to you, and you know someone else that is looking, but you are not, I'd say definitely try to make that connection there if you think they would be a good fit.
Yeah.
Yeah, and hopefully, here's to a good 2024.
Yeah, yeah, I completely coincide with that statement. Yeah, hopefully 2024 is definitely a much better year than we saw last year. But yeah, I'm sure if you have any questions around career progression and things of that nature as well, Dave will definitely be able to support you here. Also, he's been in the game for quite some time. But yeah, that's a wrap. Really appreciate your time and look forward to seeing you guys on the next episode. Take care.
Yeah, awesome. Thank you, Dom. Take
No
care.
worries. Thanks for having you, Dave. Take care. Bye.
Yeah, bye.